Okay, so let's do the next example. We would like to write the cotangent of the inverse sine of 3x as an algebraic expression. And we have this restriction on x here. What we're going to do to begin is we're going to introduce a variable, call it u. You can pick any letter you want, okay, except for x. I'm going to let u be this entire expression that is inside the parentheses of cotangent. So I've now got u is the inverse sine of 3x. All right. So what we've got here is the cotangent of inverse sine of 3x. Oops. Okay. But notice what I'm doing now. I'm letting all of this stuff here in red, we're allowing that to be equal to u. Okay, so now I've got the cotangent of angle u. All right, but if you notice that I've got x's now between 0 and 1/3. If I took this entire inequality, this statement here, and I multiplied everything by 3, 0 times 3 would give me 0. X times 3 would give me 3x. And then 1/3 times 3 would give me 1. Okay. So now I know that this 3x here is the same 3x that lies here in my inverse sine function. And I know that this expression in here, 3x, is going to be a positive number because it lies in that positive interval. So I know that if I plug in a positive number into an inverse sine function, it's going to give me an angle in quadrant 1. Okay? So really what that tells me now is that I'm trying to evaluate the cotangent of an angle u that lies in quadrant 1. All right, so what I'm going to do is I'm going to now take this statement in red, and I'm going to now rewrite it using a sine function. I know that the sine of angle u would now equal 3x over 1. Okay? So now that allows me to build a triangle. I've got angle u, which is in quadrant 1. Okay. By definition, the sine is what, folks? We know that that is opposite over hypotenuse, right? So here is our angle u. That would now mean that I've got the opposite would be 3x, and the hypotenuse would now be 1. Okay? But I would like to use this triangle now and take the cotangent of that angle u. But what is cotangent? By definition, cotangent is what? Adjacent over adjacent over opposite. All right? Okay. So on the triangle, notice what do we have? 3x is the opposite. 1 is the hypotenuse. And we're missing the adjacent, and we need the adjacent in order to complete the cotangent. Okay, so let's call that adjacent the question mark. That's our mystery value that we're trying to find. That's the mystery length that we're trying to find. Okay, but I know that these three sides are related to each other by the Pythagorean theorem. I know that our adjacent side squared plus our opposite side squared would now have to add up to our hypotenuse squared. Okay, now all we have to do is solve for the question mark, and that will give us our adjacent side. Okay, So, oops. Question mark squared plus 9x squared equals 1. Subtract 9x squared from both sides. And then apply square root. Okay? Now, if I apply the square root, you would agree that there are two solutions, a positive and a negative. But in this example, the question mark represents the length of a triangle, so it would have to be the positive. Okay? So now we know what the adjacent side is. All right, so now let's go back over here. We've got the cotangent of angle U. Okay? But cotangent in quadrant 1 is positive, right? So we know that this angle is in quadrant 1. So now all we have to do is set up a ratio of adjacent, which is the square root of 1 minus 9x squared, all that divided by the opposite, which is 3x. Right? So there we have it. Adjacent side divided by opposite side, and it gives us that ratio. Okay, and that is true for x's that lie in this interval here. Okay, so notice that we could not allow x to be equal to 0, because if x was equal to 0, then the inverse sign of 0 is 0, and the cotangent function at 0 is undefined. Okay, so there's no equality there. All right. Study